Welcome to Simultaneous Equations Level 4. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 4x equals 9 minus 3y and y equals 6 minus 2x. Now looking at the second equation, this is written with y as a subject, and when this is the case, it tends to be easier to solve these problems by substitution. And what this means is that we're going to take the 6 minus 2x, which we know from the second equation is equal to y, and substitute it into y in the first equation. So what this means is that the first equation, 4x is equal to 9 minus 3y, becomes 4x is equal to 9 minus 3, and then we substitute the y for 6 minus 2x from the second equation. Now we can start solving this equation by expanding the bracket. So we have 4x is equal to 9, and then minus 3 times 6 is minus 18, and minus 3 times minus 2x is plus 6x. Now looking at the right hand side, we can simplify this by collecting together the like terms. And we have 9 minus 18, and this gives us minus 9. So the equation becomes 4x is equal to minus 9 plus 6x. Now there are different ways of us solving these equations, but what I'm going to do is subtract the 6x from the right hand side so that we're just left with x's on the left. And if I subtract it from the right, I also need to subtract it from the left. So on the left we've got 4x minus 6x, which gives us minus 2x. And on the right, the plus 6x and the minus 6x cancel out to just leave us with minus 9. To solve this equation, we can remove the times minus 2 in front of the x by dividing by minus 2. And we need to do exactly the same on the right. And on the left, the times minus 2 and the divide by minus 2 cancel out to leave us with x. And on the right, minus 9 divided by minus 2 just gives us 9 over 2 because the two minuses cancel out. And I could write this as 4.5, but I'm just going to leave it as 9 over 2. To now find y, we can take the second equation because y is already the subject, and we can substitute x into this equation. So y equals 6 minus 2x becomes y is equal to 6 minus 2 multiplied by 9 over 2. And since minus 2 multiplied by 9 over 2 is minus 9, this becomes y is equal to 6 minus 9, and 6 minus 9 gives us minus 3. So y is equal to minus 3. And this means our final solution to problem 1 is x is equal to 9 over 2, y is equal to minus 3. In problem 2, we're solving 2x plus y equals 7 and y equals 3x minus 2. Now again, the second equation here has y as the subject, and that means that the easiest way to solve this is going to be by using substitution. And the reason for that is we can take the 3x minus 2, which we know is equal to y, and substitute it into the first equation. So this means that the first equation, 2x plus y is equal to 7, becomes 2x plus, and we can now replace the y with 3x minus 2, and that's equal to 7. On the left, we can now collect together the like terms, so we have 2x plus 3x, which gives us 5x, minus 2 is equal to 7, and we can start solving by removing the minus 2 from the left. And we can do this by adding 2 to the left, and also adding 2 to the right. And on the left, the minus 2 and the plus 2 cancel out to give us 5x, and on the right, 7 plus 2 gives us 9. Finally, to remove the times 5 in front of the x, we can do the inverse of times 5, which is divide by 5, and do the same on the right. And on the left, the times 5 and the divide by 5 cancel out to leave us with x. And on the right, 9 divided by 5 can just be written as 9 over 5. We can also write it as 1.8, but I'm going to leave it as a fraction. We'd now like to find y. And to do this, we can use the second equation because y is already the subject. So y is equal to 3x minus 2. And we're just going to substitute in x as 9 over 5. So this becomes y is equal to 3 multiplied by 9 over 5 minus 2. And since 3 times 9 over 5 minus 2 gives us 17 over 5, y is equal to 17 over 5 or 3.4. So this means that our final answer to problem 2 is x is equal to 9 over 5, y is equal to 17 over 5. In problem 3, we're asked to find the coordinates of the point where the lines with equations x equals 2y plus 1 and 3x minus y equals 8 meet. Now, whenever you're asked to find the coordinates of a point where two lines meet, what we need to do is solve the equation simultaneously and then write down our solutions as a coordinate. Now, looking at the first equation, this is written with x as a subject. So again, we can solve this by substitution. So we're going to take this 2y plus 1 from the first equation, and because it's equal to x, we can substitute this into x in the second equation. So the second equation, 3x minus y equals 8, now becomes 3 multiplied by 2y plus 1, which we're substituting the x for, minus y is equal to 8. We can now expand the brackets on the left. So 3 multiplied by 2y gives us 6y, and 3 multiplied by 1 gives us positive 3. We still have a minus y after it and an 8 on the other side of the equation. On the left, we can simplify again by collecting together the like terms. So we have 6y minus y, which gives us 5y. We still have a plus 3, and it's still equal to 8. Looking at the left, we can now remove the plus 3, and we can do this by subtracting 3 from the left and doing the same on the right. And on the left, the plus 3 and the minus 3 cancel out to just leave us with 5y, and on the right, 8 minus 3 is 5. Finally, we can remove the times 5 from in front of the y by dividing by 5 on the left and doing the same on the right. And on the left, the times 5 and the divide by 5 cancel out to just leave us with y, and on the right, 5 divided by 5 is 1. So y equals 1 is the first part of our solution. To find x, we can now substitute this into the first equation because x is already the subject, and we can replace the y with 1. So x equals 2y plus 1 becomes x equals 2 times 1 plus 1, and since 2 times 1 plus 1 is 3, we've got x is equal to 3. Now the question asked us to give the coordinates of the point where the lines intersected. And so as a coordinate, we know that x is 3 and y is 1. So we know that these two lines will meet at the point 3, 1.